Okay, the final topic that we're going to look at is properties of shapes, and in particular, looking at angles within shapes. Okay, so these first two examples are really just some very quick revision. So what we need to remember here are all of the angle knowledge that we learned from first year onwards. So also remembering that supplementary angles are two angles that add up to give you 180 degrees. Vertical opposite angles, i.e. known as X angles, are angles that in a cross, they are the same as each other when you look across the cross. We have corresponding angles which are known as F angles, where the armpits of the F are the same angle, and also Z angles, where the armpits of the letter Z are also the exact same angle. Okay? So with that knowledge in mind, let's take a look at example 1 here. So I want to fill in all of the missing angles in the parallelogram below. So in this, look for our F angles, our X angles, our Z angles, and so on. So straight away, I'm thinking that we have a letter Z here. It's a parallelogram, so that and that are both parallel. So I must have 26 degrees up here. I'll have 73 degrees here. In this triangle over here at the left-hand side, if I've got 51 and 73, take away from 180, that'll give me 56 degrees in here. So that has to be 56 degrees over here. So this here has to be 51 degrees. And then finally, looking for this angle here, I'm marking with the blue dot. That's just going to be 180, take away 73, which will give me 107 degrees. So that will be 107 degrees. In the bottom triangle, we have 107 plus 26. Away from 180 gives us 47, and it'll be the exact same up here of 47 degrees. Okay, that should not be new to us in the slightest. Example 2, we have a regular 12-sided polygon. So if it's a regular shape, then all the sides are the exact same size. Calculate the size of the shaded angle. So remember, in a full turn, altogether we have 360 degrees. So it's 360 divided by 12. So that will give me the size of the angle in the middle of each triangle. So 360 divided by 12 gives me 30 degrees. So that means that in every single triangle, this angle here is going to be 30 degrees, and so on. So let's look at one of those triangles separately. So if this angle here is 30 degrees, and we know that these are the exact same size, it's an isosceles triangle, I can work out the size of this angle here. So it's going to be 180, take away 30, which is 150 degrees. Then divide that by 2, so we get 75 degrees. So that angle there is going to be 75, this will be 75, so altogether that's going to give me 150 degrees. Okay? Let's take a look at the next example. This time we're going to use our knowledge of angles in order to fill out missing angles within the circle. So for circles, what we have to remember here is that in the first circle diagram here, whenever we have two radiuses, or it should be radii if we're talking about plural, two radii in a circle will always form an isosceles triangle because radiuses are always the same. So if you know what the radius is, you can join the end of the two radiuses up to make your isosceles triangle. Also, you'll remember that in a semicircle, if I was to draw two chords in a semicircle, it doesn't matter where I draw these two chords. I could draw the chord up to here and then down to here. They will always meet at right angles. Always. Okay? That always happens in a semicircle. And finally, When a circle meets a line at a tangent, so when we say tangent, it means it just meets the circle at one point and one point only. The tangent always meets the circle at right angles to the centre. So if I have a line intersecting the circle just at one point on the edge, then it's meeting at right angles to the centre. So then that allows us to make right angle triangles out like that. Okay? So example 3, it says, fill in all the missing angles in the diagrams below. So the first thing that we have here is, we've got a circle where we've got centre O. Now, if the line is going through the centre from one side to the other, you can assume that it's cutting the circle in half. So that means that we're dealing with a semicircle. So if this line here is a chord, and this line here is a chord, they must meet at right angles. Okay? So that means that if that angle there is 53 degrees, and I know that the right angle is down here, I can fill in the size of this angle I'm marking with the blue dot. So 180, take away 90, take away 53. So this angle up here has to be 37 degrees. Now remember what I said, radiuses are always the same going around the circle, and when you've got radiuses joined end to end, they make an isosceles triangle. So these triangles are actually isosceles. So that means that if that's 37 there, this will be 37 degrees here. If this is 53 degrees, this will be 53 degrees here as well. And I can find the size of this angle here and this angle here by just doing our sum away from 180. So 53 plus 53 away from 180, this angle here will be 74 degrees. Then we have 37 plus 37 away from 180 will give us 106 degrees. Okay? Let's look at example 3b. So fill in all the size of all the missing angles here. So this time, let's look at what we can. So we have a tangent meeting the circle. So tangents always meet the circle at right angles. So altogether, you can assume that's a right angle. So looking at the full triangle here, altogether, if one's 90 and one's 20, this angle here has to be 70 degrees to add it up to 180. So again, we also know that this side here and this side here are the same. So that means that these two angles here also have to be the same. So I'm going to work out 180 take away 70, which will give me 110 degrees. So then it'll be 110 divided by 2, which will give me 55 degrees. So what I've marked there with the red dots will be 55 degrees. And that allows me to work out the size of the angles on the other side. So the one here that I'm marking here with the black dot, that's going to be 180 take away 55, which will be 125. And then in the triangle, 125 plus 20 is 145. So 180 take away 145, this angle up here has to be 35 degrees. Okay? We could also fill in the size of this angle here. So if this angle on the left is 70, this angle here has to be 180 take away 70, which will be 110 degrees. Okay, that's angles within circles.